fine. We'll just scrub it. Okay.
Howdy. Our project is titled GAN-demonium, a look into the latent space. And our paper that we're basing this off of is called Dual StyleGAN. And this is based on the famous NVIDIA StyleGAN paper. And the whole idea that we're trying to do is, say you have a face right here, and we'd like to transfer some style onto that face. So imagine like a street artist trying to paint a person in some style. So first we align the image, and say we have the style of this Disney princess here. And from there, you can kind of see how using their architecture, they're able to transfer from the image to that princess style right here. And so they've also been able to do this interpolation between the original face and the end style. So here we're interpolating across color on the x-axis, and then on the y-axis, we're interpolating across structure. So as you can see, they're able to successfully transfer the style onto this image.
So the reason their method has been working so well is because like the model has seen a lot of data and it has learned like a numerous style from a number of like cartoon data set. However, to verify that the model actually has the robustness to kind of like generate to a different data set, we also build our custom data set from the face detectors, view of retrain model face detectors in order to like crop out the images from two cartoon series. As you can see here in the screen, some example from our custom build data set. And also we try to do some augmentation on top of those custom data set. For example, here you got like Gaussian blurring. You can also do some kind of like lighting adjustment on top of the original image. And you can also like randomly crop out small patches of the original image, as you can see here on the screen. And you can also like do rotation of the original image and flip them. And finally, you can also do like color jittering. So we were able to like fine tune their custom data set with their pre-trained model, and we have been observing some very interesting results. So one advantage of like using this pre-trained of this custom build data set is that we can kind of like create some extreme test case to see how well the model perform. And with that, I'm gonna hand it to Mario.
Yeah, so as Wen and Zach mentioned, after preparing and training the data, we were able to reproduce the dual GAN's baseline results. And what we also did was also add an architectural experimentation by adding an attention layer. By adding an attention layer, we were able to gather more structural features based off the extrinsic training. And what we have here is the results of that. From the left is being an input, and then the right being both interpolating both the structural and the extrinsic styles. And then also, just as Zach had showed later, in the x-axis, it still retains the color gradients, and also in the y-axis, it still retains the structure. And then the bottom right has a combination of the two. And this is in comparison to what dual StyleGAN had. And with that, pass it back to Zach.
And so another thing we wanted to look at in our analysis was the just looking under the hood a little bit. So in this generative model, we have a series of layers that gradually increase the resolution of the input image. So we start very coarse at the low layers, and as we do these upsampling and these styled convolutions with adaptive instance normalization, we see a greater and greater structure, and things start to resemble more of the facial data that we are more easily able to interpret. And so another thing we looked at was, given the encoding of the extrinsic styles, how can we reason or intuit from that data? And so using the uniform manifold approximation projection dimensionality reduction algorithm, we've been able to project that information onto two dimensions, which we see here. And the last thing we did in this analysis was we examined the singular values of the mapped extrinsic styles in the latent space to determine if there's any trends there. But as we found, the variance that it gets explained across the singular values is relatively consistent which just goes to show that the model is using the majority of its span.
Yeah, so just for concluding, we were able to reproduce the baseline results from the dual StyleGAN. We're able to explore each trip in the latent space based off the data augmentation that from the work that Huan had done, and then also implementing an attention layer. And then from there, we're able to get some interesting results that are located in our paper. And with that,
We
we
are
are
GAN-demonium
GAN-demonium, and good night, Las Vegas.